if you, okay. And if, yeah,
say it again, please.
and if you can upload the lecture before 1 day, if you can.
Oh, yeah, actually I uploaded yesterday night the lecture, so you could just watch it this morning. So I uploaded this yesterday, actually late a little bit. So you want to have it day before, right?
If you can upload last, how can I say it? Before 1 day at
Okay.
to
I
be
see, I
to,
see.
to
I
be
understand.
to be ready to the
Yeah.
particle.
Okay, okay. Yeah, I understand. I'll upload 1 day before. Yeah. That's not even 2 or 3 days before it can be also.
Okay, thank you, my doctor.
All right. Any other questions? All right, so we stopped here. So we want to understand, this is very important. We need to understand this is very well. And then, yeah, so we can go on. I asked the question, so what's going to be the mass of 2 moles of hydrogen, for example? Say we have 2 moles of hydrogen, what's going to be the mass of that?
2 grams.
Yeah, exactly. It's going to be 2 grams. Yeah.
Yes.
So it means that the molar mass of hydrogen is 1 gram per mole, because we said that the mass of 1 mole of hydrogen is 1 gram, right? So since it is the true, so it means that the molar mass of hydrogen is 1 gram per mole. Okay, so don't forget that the molar mass unit for the molar mass is gram per mole. That's the unit, gram per mole. Okay, so if I say that 1 mole of nitrogen, the mass of 1 mole of nitrogen is 14 grams. So it means that molar mass of nitrogen is 14 grams per mole.
Per mole.
Okay, so this is the hydrogen atom, right? So if I have a hydrogen molecule, which is H2, what's going to be the molar mass of hydrogen molecule? How do you think?
2 mole.
2 grams per mole.
Yeah, 2 grams per mole. Yes, right. So the molar mass for hydrogen molecule is going to be 2 grams per mole. Now let's see what is the relationship between moles, between grams, and Avogadro's number. This is very important. These 3 parameters, we need to understand how they are interrelated. Again, if we have 1 mole of element, it means that we have 6.022 times 10 in power 23 number of atoms, for example, in there. Okay, it means that we have 1 mole of substance. It means that we have more. If we measure the mass of that substance, we will find that this is molar mass of that substance. Okay, so now let's just look how they are related. So say mass of element over here, mass of element, which is indicated as small m, like okay, so if we want to find number of moles of elements, we need to divide mass of element on molar mass of that element. Okay, so if we want to find number of elements in that amount of mass or moles, so then we need to multiply number of moles by Avogadro's number. Okay, so if we want to go back to find out from number of elements to find out number of moles of elements, we need to divide this amount by Avogadro's number. And then if we want to go even further to find mass of element, we need to multiply molar mass by number of moles. We will find out the mass of element. Okay. I have another
Sorry,
case.
sir,
Yeah?
I have a question. Will we be given the molar mass in the question,
Molar masses
or
will
at
be
least
given.
the periodic
Yes.
table?
Yeah, you will be given molar masses, or you will be given periodic table. You need to find molar masses. Yeah, you don't need to remember.
Because in the last page of this lecture, the second question was about zinc, and there was no molar mass given in this question.
Yeah, so okay, so if it is not given, if you do it, say if you are at home, right, and if you have an internet, you just can Google it and find it, the molar mass. But on exam or on quizzes, you will be given the molar masses, so you don't need to remember all molar masses, like because I don't remember myself. But it's good if you know some very common elements, say hydrogen, carbon. You need to know the carbon definitely. Oxygen, nitrogen, you know, things like this.
But my question is that it will be given in the midterm or in the final.
This kind of things will be given in the midterm. I'll tell you once the time is for midterm, I'll give you the topics, what you need to prepare for. But right now we are studying this. Since I'm explaining this, it means that you have to study it. No matter it's in the midterm or in the final, it doesn't matter at all. We are here not only for midterm or for final, we are here for knowledge, okay? So since I'm talking about this, it means that you have to study this. And yes, it will be in the midterm as well, okay?
Okay, thank you.
Doctor,
Yes.
Doctor, I want to ask you about the significant figures.
Yeah.
It should, in the answer, it should be.
Okay, I don't.
The answer.
Oh, okay. About sig fix, I'm not really pressing on sig fix. At this moment, I don't consider that important sig fix. Okay,
That is
but in general, yeah, you have to try to have correct sig fix in general. But at this point, I'm not taking points off or anything for sig fix.
Yeah, thank you.
Okay, so
Sorry, sir,
let's
but the previous lecture.
Yes.
Sorry.
Yeah.
In the previous lecture, we were told that we should write the answers by two significant figures.
No, this is about the burette. So I told you about the taking reading from burette. That's the very important thing. It's a different story. You need to take a reading from burette using 2 decimal places. Okay, so that's the mandatory for taking the reading from burette. But if we are doing calculations beyond dealing with burette or anything like this, just on a paper. So it's not, I'm not pressing that much on sig fix. But in the lab, when we are in the lab, so if it says about burette that you have to take 2 decimal places, then you have to take 2 decimal places for burette. Okay, and also sometimes it might tell you that take readings from the mass 3 decimal places. So then you will write 3 decimal places, okay? But then you can round it. Once you do calculations, you can round it to 2 decimal places, for example. But for burette, yeah, it's mandatory to take 2 decimal places, okay? And whatever sig fix is that, it's 3 sig fix usually, or 4 sig fix. Either it's 3 sig fix or it's either 4 sig fix, because sometimes burette you have like, say 0.01 milliliter or 25.05 milliliter. So then either it's 3 or either it's 4 sig fix. But it should be 2 decimal places for burette. But it's about burette. It's really because we are doing practical stuff, so it's kind of important. But I'm saying again, if you want to keep exact sig fix, that's fine. I mean, it's okay. You can do that way. It's good actually if you do like that way. But again, during the calculations, I might not be pressing that much. All right, so let's just look at this scheme. Again, this is about the relationship between mass, between moles, and between Avogadro's number, basically. So if you want to go from grams to moles, you need to divide amount of substance which is given in grams by molar mass. Okay, sometimes it's called also atomic mass, but also it's called molar mass. So if you want to go from grams to moles, you need to divide grams per molar mass, because now look, so if you have grams, say you have 5 grams of carbon, right? So how to move from grams to moles? We know that molar mass of carbon is 12 gram per mole. Okay, so how to change mass to moles? As it says over here, you need to divide 5 grams divided by 12 grams per mole, right? Now let's look how units will be changed. So gram and gram is cancelled, mole will go up, and you will have so if it's going to be 0.4 right, and then we have 20, yeah, so it's about 0.4 moles. Okay, is it clear?
It's
So
clear.
if you want to go,
Yes, Doctor.
if you want
Can you
to,
repeat this?
yeah, so if you have amount of substance in grams, say you have 5 grams of carbon, okay, and you want to find out how many moles of carbon you have. If you have 5 grams of carbon, you need to divide 5 grams of carbon by molar mass of carbon. This is the molar mass of carbon, 12 grams per mole. So if you divide 5 grams by 12 grams per mole, grams and grams are cancelled, right? And the only thing you left with is mole. So it means that you divide 5 by 12, it's about 0.4 moles. So this is the amount in moles of 5 grams of carbon. Okay. Is it okay?
It's
All
okay.
right. So
Yes,
Thank you.
It's okay.
okay, so if you want to change moles to number of atoms of molecules or molecules, what you are doing if you want to go from here to here, so what you are doing is that you are dividing moles by Avogadro's number. I'm sorry. No, I'm sorry. You are multiplying. You don't divide. You multiply it by Avogadro's number. Okay. So if you want to go from moles, it says over here the arrow goes like this way, right? So you multiply number of moles by Avogadro's number to find atoms or molecules in that number of moles. For example, if you have 2 moles of carbon, it means that you multiply 2 by 6.0.02 times 10 in power 23. It's going to be 12 times 10 in power 23. Number of atoms or molecules. Okay. So if you want to go backwards, so if you have number of atoms, you want to find moles, then you divide it by Avogadro's number, and you will find the number of moles. Okay. And if you know the number of moles and you want to find the mass of that substance, you just multiply it by molar mass and you will find the grams of that substance. So basically the same, just going backward, you can find whatever you want. So this scheme is quite descriptive in that sense. The same thing is given like this: moles to atom or molecules, conversion moles to atom of molecules. So moles by Avogadro's number, okay? Moles to grams, moles by molar mass. Atom or molecules to moles, number of atoms or molecules divided by Avogadro's number. And grams to moles, grams divided by molar mass. Okay, so you can use this scheme to manipulate with moles, with grams, with atoms or molecules, number of atoms or molecules, and so on and so on. Any questions here?
No, thank you.
No,
Okay,
thank
right?
you, Victor.
All right, so let's
It's
just look.
okay.
Let's just consider some chemistry, like chemistry related things. By the way, there's 1 mole of, for example, if you take 1 mole of orange, right? For example, it's a huge number. 1 mole is just a huge number. It says over here, how big is a mole? So 1 mole of sand, just the sand. You know how small is the sand grain? If you take 1 mole of sand grains, it would cover the area of Los Angeles to height of 600 meters. Okay, it's a crazy big number. So if you take, for example, oranges, right? So imagine that you have Avogadro's number of oranges, right? It's a huge number. You can cover the whole earth by oranges. It's such a big number, this Avogadro's number, okay? Unimaginably big number. So you can see you are dealing with so many atoms in order to have some visible reaction. This is why it's inconvenient to deal with only 1 atom, right? So you need really like huge amount of atoms to really visualize the effect of reaction. So molecular mass, again, when we are talking about vast number of molecules or formula units that take part in a visible chemical reaction, it is convenient to use counting units called a mole, okay, just as a mole. For example, if you look at this reaction, it says that 1 mole of ethylene reacting with 1 mole of hydrochloric acid, you make 1 mole of ethyl chloride, okay? So when I will talk about this one in more details, but by now you can just look at this reaction, and it means that you have 1 mole of this, 1 mole of this, and 1 mole of this. By the way, ethyl chloride is often used as a spray on anesthetic for athletic injuries, because once you release it, it's like endothermic reactions, endothermic process, so it cools down the area. I'll skip this. I don't think they really need this, but I want you to look at this here. It asks how much 0.25 mole of water weighs. So we need to find out the mass of 0.25 mole of water. Okay, so the molecular weight of water is given here, over here, right? So it's 2 times 1 gram per mole of hydrogen plus 16 gram per mole of oxygen. So I'll just remind you, so this is for this part. Okay, this part is for hydrogen, and the other part is for oxygen. So this is how you find the molecular weight of water. Okay, so overall it turns out that this is 18.0 gram per mole. Okay, so the molar mass of water is 18 gram. 1 mole of water is 18 gram of water. All right, so now let's just see how many grams, how much water we have if we have 0.25 moles of water, right? We know the molar mass of water. So by the way, how we make the molar mass of substances, we're just adding components of that substance to each other. So find out the final molar mass of that substance. This is how we find out the molar weight of water. So now we know molar weight of water. So if we go back, say if we go back, so look, we know moles, right? And we know molar mass, and we need to find grams, right? So what we need to do, we need to multiply moles by atomic mass or molar mass, right? So it means that we need to multiply number of moles by molar mass. Okay, and we'll find out that this is 4.5 gram per 5 gram of water. Okay. Now let's just see what's gonna be the next one. How many moles of water are in 25 grams of water? So the conversion factor is 1 mole over 18 grams. So this is basically the molar mass of water. We know that it's 18 grams per mole, right? Can you think what we should do here? So that's the 18 grams per mole. So we know mass of water, we know molar mass of water. Those only thing we need to find out is number of moles of water.
Yes.
Yes. So do we have an answer?
Yeah. We can. I have right now mass of water and mold, and I need right now a molar mass. Yes.
No,
It's
you need to
1.5
find
mole.
you need to find number of moles.
Yeah. Number of moles.
Right.
Yeah. You must be to multiply moles by number of Avogadro.
Okay, so no, you don't need that many.
Doctor, it's 1.5 mole, right?
Okay, let's see if it is 1.5 mole. Now let's just think before we do any calculations. So we know that molar mass of water is 18 grams per mole, right? So if we take 1 mole of water, it means that it will weigh 18 grams, right?
Right.
We are given 27 grams of water. So how do you think it should be more than 1 mole or it should be less than 1 mole?
More than 1 mole.
Of course, it's going to be more than 1 mole, right? So
Yes.
Yes.
if we consider like this way, 1 mole of water is 18 grams, right? This is what we know. So 27 grams is going to be X moles, right?
Right.
So from here, you can find out that how to find out the X. So what you need to do is that you need to divide 27 by 18, right?
Right.
It's just cross multiplication. So then if we divide, so number of moles, say X moles is going to be 27 grams divided by 18 gram per mole, right? Okay, so how much is the 27 divided by 18?
1.5.
1.5.
Yeah, so then this number is okay. So this is okay number. So it makes sense, right? It must be more than 1. So we got more than 1, which is 1.5 moles. So number of moles of water, which is 27 grams, it's going to be 1.5 moles of water. Okay? Is that clear for everyone, or we should discuss a little more?
No, that's okay.
It's clear.
It's okay, right?
Good.
Let's
Thank
just
you.
remove this one over here. So yeah, so it's the same thing. Basically, if you, so there is a the same thing, right? So 27 basically multiplied 1/18 is the same as 27 divided by 18 grams. It's the same thing, right? Mathematically, we don't do anything different. Okay, so I want you to practice this at home, this kind of thing, because it really strengthens your knowledge. And then something similar we might have, say, in the exam or anything like this. So it really helps you to have an idea about how to convert grams to moles, moles to grams, and so on and so on. So I want you to practice this one at home, all these three questions. Okay. Also, I told you that we will have some quizzes. So in the quizzes, we will have something similar. Okay. Now let's just go through the lecture I uploaded. I want to go through that, and I'll stop this. Any questions here? All right.
No.
Okay, so then let's just go with the lecture which I uploaded quickly. Just you will watch this lecture, but you know, we can just also talk here in details about chemical reactions. I have only 10 minutes left, but let's just talk about this, and then we continue in the next class. So this lecture is about chemical reactions. So we need to understand what is chemical reaction, because we are talking about chemistry, right? And how the chemical reactions are written down using chemical equations. So there is a process going on, but you need to somehow describe this process, right? If you want to describe some kind of event, you are just writing words, but in chemistry, you are writing equations, okay? And everything in chemistry, when it's happening as a reaction, there is a particular amount reacting with another substance, which also, so with particular amount of other substance. And all these amounts are absolutely balanced, okay? So usually some chemicals react with another chemicals in particular balance, all right? So it's kind of reminds you cooking, for example. You take some portions of ingredients, right? And if you take, say, if you want to make a hamburger, you will take, say, 2 pieces of bread, 2 pieces of meat, say, and say 1 piece of cheese, and you will make 1 hamburger, right? So you cannot make 2 hamburgers from this amount of ingredients. So the same thing in chemistry. So if you don't take particular amount of chemicals at the very beginning, you will not make whatever you want to have at the very end. Okay. So what is chemical reaction? It's a process in which a substance or substances is changed into one or more new substances. Definitely, you need to have a change during chemical reaction. If there is no change, it means that there is no reaction. Okay. Very important thing is law of conservation of mass, because again, you need to have whatever you started with, you need to end up with the same amount. Yes, it will be different substance, but the overall amount is the same. As I'm saying about this hamburger, right? So you started with bread and you ended with the same amount of bread, right? Before you eat something, you will have exactly the same amount of bread in the hamburger, right? So you started piece by piece, you built up the hamburger. So now you have different kind of stuff, but the amount of ingredients is the same, right? You agree, guys, with that, right? So the same thing about chemistry and chemical equations. So you need to balance chemical equations to have, you know, initial and final amounts the same. Okay. So how you balancing that? You will write the chemical equation. Very important is that you have right formulas. Okay, that's the very important. Otherwise, it will not be balanced at all. So first of all, we need to know what's going to be the right formula. Okay, and then once we have it, then we need to use some coefficients to balance this chemical equation. Then we'll check it and we'll make sure that all coefficients are okay. For example, if you look at this equation here, so sodium perchlorate, it decomposes to, so it decomposes to sodium chloride and oxygen. By the way, this is the oxygen which is used in on planes. So see, before there is no coefficients, so we don't have any coefficients here. But if you count the amount of substances here and elements, it will not be the same from left-hand side and right-hand side. Say if you count sodium, okay, it's 1. Also, it's 1 here. Chlorine, it's 1. Also, it's 1 here. But oxygen, we have 3 oxygens here. We have only 2 oxygens here. So we need to balance this situation. Otherwise, it's not going to be correct process. Okay. So we will never understand how much we need to take sodium perchlorate to make the sodium chloride and oxygen. So to balance it, you just, if you write 2 instead in front of this equation here. So now let's just count again in this mode, in this case. So how many sodium we have? Can you tell me?
2.
2. What about chlorine?
1, 2.
2.
Okay, don't be mistake. We do not have 1. We have 2 because these 2 belongs to everything here. Okay, it just belongs to everything here. So we have 2 sodium. We have 2 chlorine. What about oxygen?
6 question. Yeah,
Exactly.
6.
We have 6 oxygens here. Just remember 2 sodium, 2 chlorine, 6 oxygens. Now let's just go to the left-hand side. How many sodium we have?
2.
2. The chlorine also 2, right?
2, yeah.
Yeah.
And oxygen we have 6.
6.
Yes.
Now everything is balanced. So this equation is balanced. Okay. So we need
Doctor.
always to pay attention to balance reactions.
Doctor,
Yes.
we must balance electronic or just mode.
Okay, so in this particular case, you just balance. Right now, just you balance moles, but you can come to this decision using electrons exchanged between this oxygen and this oxygen. Okay.
And now not required.
So you can also use, again, what I'm saying, you can also use, because here you have, but we will not be talking about right now about this, because this is redox reaction. So you can see that chlorine here is +5, over here is +5, okay? And then chlorine here is -1. So it means that 6 electrons were exchanged between this chlorine and this chlorine. The same thing about oxygen. So oxygen was -2 over here, now it's 0. It means that 6 chlorines from oxygen went to chlorine. Okay, and this is why we have 6 oxygen over here and 6 oxygen over here, because we need 6 electrons for chlorine. Okay, but right now I don't want you to go like count electrons here, so you can just find
just
out
more.
just
Mole.
moles. These moles are very much related to electrons, because again, we need 6 oxygens in order to provide 6 electrons for chlorine. Okay. Another thing
Oh.
I want you to pay attention is that see some kind of letters are written at the end of the compound, right? It says here S, here it's also S, it says L, it says G. So it means that this is going to be S, it's going to be solid, and this is like a solid. Then you make carbonate or sodium carbonate, it's also solid, okay? And this is liquid as water, and this is gas because it's carbon dioxide. That's a gas, okay? So these coefficients are called stoichiometric coefficients. And in chemical reactions, these stoichiometric coefficients can be interpreted as number of moles of each substance. For example, if you take nitrogen and react with hydrogen, you will make ammonia. Okay. Now, how can we interpret these numbers in front of these chemicals? There is nothing written here, but it's implied that this should be 1. It means that this is 1 over here, but it's not usually written. Okay. I have less than 1 minute, but let's just finish and that's it. We'll continue next week about these topics. So it means that we have one, you can interpret it as 1 molecule of nitrogen, 3 molecules of hydrogen, or 2 molecules of ammonia. At the same time, you can consider it as 1 mole, 3 moles, 2 moles. Why? Because we can just multiply it by Avogadro's number and we can get moles in there. So nothing will change in terms of amount, ratios of amounts of these